Hi there. My name is Jake Kahn, and I'm interviewing for the high school math teacher position at Coursello. Today, you're going to hear me talk about the Algebra 2 lesson on transformations of periodic functions. Um, I'm going to focus specifically on the opening of the lesson, so this is going to be slides 4 and 5. You'll hear me throughout the lesson talk as a teacher, obviously, but you'll also hear me interject with student responses that I would expect to happen in a lesson like this. So here we go. Hello, everyone. Welcome back to class. Thank you so much for being here with us today as we talk about transformations of periodic functions. If you're thinking to yourself as I said that lesson title, hey, Mr. Kahn, haven't you talked about transformations already? We're doing this again? And I would say, student, not just once, not just twice have we talked about transformations, but we've talked about transformations about 5 times this year. We've talked about transformations with quadratics, cubics, polynomials of higher degree than that. We've talked about them in terms of radicals, logarithms, exponential functions. We've talked about transformations a lot. We're going to apply it to a new type of function today called periodic functions. That includes things that you may have heard in geometry, things like sine, cosine, or tangent functions. But before we get to those new types of functions, let's talk about what you already know and just give your brain a little bit of a refresher to start off today's lesson. This is when I would put up slide number 4, which is the description of the 4 major types of transformations. So, class, what you see in front of you right now is the 4 types of transformations that we have talked about throughout this year. And what I would like us to do is give an example of each quadrant before we talk about periodic functions. So let's start out with the top left quadrant, which says translations. Remember that throughout the year, we've talked about horizontal and vertical translations, right, left, and up, down movement. I'm going to start off with a specific question and then I'll get more open-ended as we review the rest. But let's start with a very specific question, and I want hands raised virtually for this. I'll call on someone. Let's say that we have y equals the square root of x, the parent square root function. And let's say that we translate the parent square root function up by 3 units. Y equals square root of x, we are going to translate it up by 3 units. What would the equation of that function be? I would wait for a little bit, hopefully get a good number of hands raised virtually in the call. And I'm going to call on Kimura. Kimura says, Mr. Kahn, the equation of that function would be y equals the square root of x plus 3. And I would say, Kimura, that's awesome, but because we're on a call and we're not writing this on paper, I need you to be more specific. Do you mean that the plus 3 is inside of the radical, or is it on the outside of the radical? Kamara would think, and she would respond to the class / to me. She would say, Mr. Kahn, plus 3 would be on the outside of the radical because plus 3 on the outside would be a C value of 3, meaning vertical translation. I'd say, awesome. Thank you for those specifics, Kamara. Let's jump off of that question, though, in that situation. Let's say that instead of the plus 3 on the outside, let's say that we had it on the inside. Y equals the square root of x plus 3 inside of the radical. What direction would it move now? Would it translate to the right, to the left, up, or down? Could I have somebody else respond and give their reasoning? I would give some time for hands raised, and let's say Anthony raises his hand and he says really confidently, he says, Mr. Kahn, when we have y equals square root of x plus 3, we would move to the right by 3 because inside is horizontal translation. I would say, Anthony, thank you so much for your input. You are correct in that it's horizontal translation. But I think we may be forgetting 3 important words that we've talked about in terms of horizontal translation earlier this year. What am I talking about, class? 3 small but important words when we are dealing with horizontal translation. Class, could you type those 3 important words for me in chat right now? Hopefully, what I would see in chat, if I was teaching them, I would definitely see this. From our previous units, I would see in all caps, A always lies. And this is what I tell my students to remember, that the signs don't work how they usually do as far as pluses and minuses. So back to it. I would see the chat responses and I would say, awesome students, thank you for that reminder about how horizontal translation works with those signs. Remember, it can be a little bit confusing, a little bit tricky. If you see a +3 inside of the radical, because a always lies, it's trying to trick you, it actually means that the function translates to the left by 3. Now more open-ended, instead of giving you a specific question, I just want 3 different individuals to give me an example for each one of the quadrants that we have left. So vertical transformations, we can vertically stretch a function or vertically shrink a function. Could I have somebody raise their hand and tell me what is an example of a function, any function, that stretches or shrinks vertically? I'll wait and then I'll call on Daniel. Daniel says, the square root function, if we stretched it vertically by 3, would be y equals 3 square root of x. I'd say great work. Way to include the 3 on the outside of the radical. Remember, 3 is greater than 1, so it'd stretch. If the absolute value of that value is less than 1, it would shrink vertically. Next, I'd be looking for an example, Next, let's get an example of horizontal stretching or shrinking. And we are going to call on Kayla. Kayla, go ahead, give us our example. And Kayla would say, let's say that the sine function, y equals sine of x, we are going to shrink it by a factor of 3. So we're going to write y equals sine of, in parentheses, 3x. I would say, awesome, Kayla. Way to go, remembering that shrinking and stretching works a little bit differently when we are dealing with horizontal scaling. 3, rather than stretching it vertically like we would expect, horizontally it actually shrinks the function and smushes it together. Lastly, let's get an example of reflection. We talked about horizontal reflection across the y-axis, and we've also talked about vertical reflection across the x-axis. Could somebody give me an example of a function that does either one of those things? Let's say that Andre raises his hand, and Andre says, Mr. Kahn, the cubic function, if it was reflected across the x-axis, would be y equals negative x cubed. And I would say, awesome work. A negative in front of the function indicates vertical reflection. We are going to move on now to our new material, dealing with how transformations apply to periodic functions. Make sure you're taking good notes on this stuff and try to be thinking about the connections to what we have just discussed with these new types of functions. This is where I put up slide number 5. Students would be taking notes per my instruction, and I'm also going to be asking some questions. Class, so what you see here are 3 new vocab terms. However, just because they look new doesn't mean that they're coming completely out of the blue, right? What we always do in math is connect new knowledge to old knowledge, so we're going to be doing that with our slide in front of us here. Amplitude is the first new vocab term that you need to know, and the amplitude is half of the height of a function. So you may be thinking, half of the height of a function, why have we never heard of that before? That seems like a pretty basic thing, right? And let's think about that a little bit more, y'all. Why have we never talked about amplitude in class? Amplitude is half the height of a function. What are the functions that we've talked about so far? We've talked about quadratics, cubics, talked about square roots, we've talked about exponentials and logarithms. Think to yourself here, why do we not use amplitude to describe those functions? And this hopefully gets their brains turning, thinking back to all the functions and their graphs that they've seen over the course of the year, and hopefully somebody would raise their hand, and let's say that Melissa raises her hand. Melissa, go ahead. And Melissa says, well, all of those functions had infinite height because they either went forever in the positive infinite direction or they went forever in the negative infinite direction, and they didn't have a height. And I would say, that's awesome. Yeah. All of our functions before, they either went to positive infinity or negative infinity in the y direction or both. But you're going to see with these types of functions, periodic functions, their range is restricted between two specific values. So we can actually say that this periodic function has an amplitude of 3, which means that its total height would be 6. Amplitude is half the height of a function. You can connect that to vertical stretching because the amplitude is the a value in front of the sine or the cosine. Period. Period is the length of a cycle or the shortest interval before the graph repeats. So you know how I said earlier that periodic functions are patterns, right? They repeat over and over and over again. The period is the length of one of those patterns. Make sure that you write down the equation for the period. The period is always equal to 2 pi over the absolute value of your b value, which is in front of the x inside your sine or cosine. We'll give more examples later on in the lesson about how to actually calculate that period. And then finally, phase shift is the horizontal translation of a periodic function. If you're thinking, phase shift, that sounds so cool, it sounds like a sci-fi movie, I agree with you. But really just realize that this is a fancy way of saying, does it translate to the right or to the left? Why do you think we use a different type of vocab term for periodic functions? Like, why can't we just say that it translates to the right or to the left? Think about it for a little bit, and then could I get somebody to raise their hand? And I'll give them time to think. And hopefully, this is a higher level question, thinking about a question like this, but hopefully somebody, I'm going to call on Jeremiah. Jeremiah is going to respond, Mr. Kahn, so I know with horizontal translation of other functions we've done, we haven't done functions with patterns, right? So like quadratics, they don't have a pattern that repeats over and over again, or square root functions, they don't repeat. But if periodic functions repeat, maybe we use phase shift as a term to signify that there is a pattern that repeats over and over again. And I would say that's awesome. That's why we use that term. Phase shift is used specifically for translations of functions that have those patterns that repeat over and over again. That would bring us into our next slide. I would put slide number 6 up on the screen. And this is when I would pair up students into pairs or into breakout rooms. And I would say, okay, y'all, I'm about to separate you into pairs or breakout rooms. And what you're going to do is you're going to look at the blue function. That is our parent cosine function. And I'm going to ask you, how would you describe the transformation going from the blue function to the black function? Using some of the words that we have just talked about, or maybe even words that we talked about in our review from previous units. How would you describe the transformation from blue to black? Talk about that with those partners over the course of the next few minutes. And that is about 8 minutes, maybe a little bit beyond that. Thank you so much for listening. I chose this lesson because Algebra 2 has been what I've been teaching over the last 7 years or so, and I absolutely love it. And this has been like my 50th take, because it's sometimes hard to, imagine yourself with no actual students in front of you, but, doing the whole teaching as if an entire class is in front of you. So I hope you liked it, and I'm looking forward to hearing back from you. Thank you so much for listening.